everyone, and welcome to another episode of LOH. This is LOH number 10, and today is 17th of January 2024. So, today's session, as always, we're going to start with Launchpad Development since last LOH. This is the first Launchpad of the year, Launchpad Office Hours of the year. The main thing we'll be covering today is monitoring in a highly available way. So we'll go through both how to set logging in a highly available way and how to set metrics as well. And then we'll have some time for open discussions. And yes, happy 2024 to everyone. All right, so since last LOH, some development that has happened. So on Launchpad charts, we have had new stable releases for Nimbus, Aragon, ProxyD, GraphNode, and a few others. And on Launchpad namespaces, similarly, we have had stable releases for Ingress namespace, storage namespace, monitoring, Gnosis, Ethereum, Arbitrum One, and Sealed Secret. We've also added a new monitoring, like a highly available monitoring guide on Docs. And as always, you can see links for where to submit issues if you're coming across any issues with either Launchpad charts or Launchpad namespaces. Before we start into monitoring deep dive, and I hand over to Carlos, you can see the how to deploy a monitoring stack with HA with full instructions on the docs, and Chris has links to that. Carlos, would you like me to continue sharing the screen, or are you okay to take over?
I think I'm okay. Yes, I'm okay to take over. I'm gonna try and share my screen.
Over to you then.
Which is hopefully working.
Yes.
Good. Okay, so hi everyone, and welcome. It is our intention, as Anna says, to go over, for starters, everything that's required to set up a highly available stack using Launchpad for Loki and the Kubernetes stack. But also go over some use cases and actually using it. But that's probably going to take a little bit longer than a session. It will very likely to take 2 or maybe even 3 sessions to cover all of this, but that's the plan. Unfortunately, these stacks are reasonably complex. There's like a lot of components to them, and this will be a bit long in that regard. Feel free to interrupt, to ask questions at any time. We really don't want this to be kind of like a very long presentation of going over a lot of information continuously without any sort of dynamic. So please interrupt at any time. And that says, let's start then. Okay, so just to frame a bit the question, what it is that we want from our monitoring stack, from observability. It's kind of a lot about data, and we need to collect it. Then we're very likely interested in transforming it, be it like filtering, extract the data, things from it, or just otherwise transforming it. And we want to store it, and we want to query and visualize it. This is like the main core aspect of observability. We acquire telemetry data, we process it, and we store it. And we're able to query it. And there's a second component, which is we want alerts as well. There's a signal you may be interested in extracting from the data, like some kind of processing. And when those conditions are met, we want to trigger a connection, which is basically alert manager and alerts and all of that flow or incident response. In the monitoring namespace, we use Loki. You're probably aware of that already, and we use Kubernetes stack. Kubernetes stack is a Helm chart, which basically deploys the Prometheus operator. Is really useful, and a couple of more related and useful things. But the central part really is the Prometheus operator. Oh yes, and this note. Telemetry data is usually logs, metrics, and traces. We don't yet include support for traces, so that's not going to be covered, but should be one of the three main components in terms of data that people are interested in. Okay, so let's start with logs. For logs, like I said, we use Loki, and these are some of the most important components. And we kind of have, I think it helps to have a sense of the architecture, the components, and how they relate to each other, so that we can make sense of the configurations as well, or answer questions about how many replicas we may want or need, or what it's about. So let's briefly go over that. So the Loki system is here at the starting point, a gateway for ingress. This is a deployment, and it is basically an nginx setup that just routes API calls to the other components. It's all it is. It's a path-based routing of API calls. So we have here a read path and a write path. Let's start with the write path because we just started the demo, so our database is empty. Okay, so gateway accepts push request for writing your logs. It hands them over to distributor. Distributor then hands them over to the ingester, which is the component that actually persists the logs. So why do we have this stopgap here? Why don't we just have the ingester? The distributor is in charge of doing several things. One is for scaling purposes. It actually takes queries that are sorry. Let's start somewhere else. The distributor ensures that the log is sent to more than one ingester, which allows it to not lose logs. It does replicas, basically. And this is a very important aspect to it, which is when an ingester gets a log, it's not pushed to object storage immediately. So what happens if the ingester goes down, or it crashes, or the nodes where it's running malfunctions or anything, you'll end up losing logs. So there's like this system of if somebody gets a log, it needs to write it in a certain number of copies before it acknowledges it as written. So that's the replica factor parameter, and that's its main function. And there's a formula for the quorum where you set the parameter and just like you have to have a majority of writes. Okay, that's one very important aspect of it. Then it has some option to do some rate limiting because Loki is multi-tenant aware, but I'm not sure any of you is actually interested in using it in that kind of fashion. But just be aware of it. Okay, so security gets logs, passes them to ingester, and ingester writes them eventually to object storage. It's not a thing the ingester does in between to add more durability to the data, which is it immediately writes the logs to disk. It has a write-ahead log, a wall, a journal that it commits to. So in case an ingester actually crashes when it restarts, if the data is fine, it can pick up from where it left off without loss of data. Okay, so that's the write path. The read path is kind of similar. We have a query front end and a query, and same kind of deal. Why do we just have a query, and why do we stop first at the query front end? This does a couple of useful things, one of which is caching. It caches query results. The other one of which is it takes complex queries and it breaks them down and sends them over to multiple queries, query instances. So say you have you want to have logs, you want to ask for logs from like a year or like a year period. It can break that down on like 12 months and send it to 12 queries and do that in parallel and do the processing part in parallel as well. So that's a useful feature for scaling, not only high availability. So you have those two components. Query actually executes the queries. The query frontend does that sort of thing. And they read logs from object storage. Any questions regarding this part? I'm sorry, guys. While I'm presenting, I'm actually seeing the chat. So if there's anything,
Yes,
yeah.
Chris is asking if the ingester handles deduplication before writing to the operating system. Sorry, storage.
No, it does not. The ingester just writes to disk for the read-ahead log and commits object storage. It does not handle duplication. What we do have is a service called a compactor, which handles that kind of housekeeping. One thing about Loki is that it only uses object storage as a single store setup, where both the data, the chunks of data, and the index of them is kept on object storage. There like no other database. Compactor basically regularly does that sort of housekeeping and deduplication. And in case you configure like data retention, because you want to say only keep logs for 1 year or 10 years, it does deleting and that sort of stuff. That's Compactor's role. And finally, you have roller. We won't get to this one yet, a little bit later, because I have skipped prompt tail. So this is all like the server part of the path. We're missing the most critical maybe aspect, which is actually getting the logs. And for that, we use promtail, which was the default agent to collect logs and send them to Loki. So what this does is it has a bunch of scraping paths, like scraping format accepts, things where it can ingest logs from. Then it supports kind of a pipeline for transforming them or processing them. Like you can filter them right at the ingestion part, right at the agent part of collection. And then it ships them over to Loki, where they get stores and indexed, and then they can be queries. Now that's Thumbtail's role. And okay, now finally the roller. And the roller is a component where you can set up expressions, like queries, basically. You set up queries at the roller, and it regularly evaluates those queries against the object storage data, so against your logging data. When those queries get satisfied, when those expressions get satisfied, and the expression that has some kind of a condition, you're looking for a rate of error rates like higher than 0 or higher than something, or you're looking for some kind of match to a message in the logs. When those conditions are met, it triggers an action, and basically it's also connected to Alert Manager, which we'll get to on the primitive part. So if you want that functionality, you need a roller, compactor. You want one, and only one actually. You don't want more than one running. They don't. And everything else for high availability, you'll want multiple copies. You want at least 3 ingesters so that you can have two writing, a quorum writing, and still be able to afford losing one. So the minimum for high availability ingester will be like 3 replicas. Distributors will be like 2. query frontend 2, query 2. That's the absolute minimums for high availability. Compactor is not critical. It does all of those housekeeping. If it goes down, everything works. It's just something that it's kind of like a cron job, something you want to, a task that runs periodically. And roller, you want several as well, because if you have alerts, you're interested in having them always working. Now, a little bit more, I guess, about Promtail. Given this is Kubernetes, you're very likely to be going to use Promtail with the Kubernetes scraper. It has one, which basically interacts with the Kubernetes API and gathers a bunch of data about and the logs about the pods running on the cluster. So if you deploy Promtail in Kubernetes, you basically get logs from all of those pods already. And it applies labels to them. That scraper adds a bunch of metadata fields to label the logs, kind of like tags and labels. And you have all of that metadata. You can use them to filter them and build alerts with and all of that. But at the ingestion part, since it's a component that does add the labels and all of that, it's something you're likely to want to configure at some point when you want to start customizing your labeling schema, or are you going to identify the log stars? This is probably the component you'll be looking at. Okay, any more questions about this? Architecture part, maybe. Okay, those are the main components. There's a couple of more. Just gonna mention them. Alert manager already mentioned because the ruler will be signaling alerts, shipping alerts to alert manager. Grafana is relevant because that's basically how you visualize logs. It gives you a nice interface where you can input queries, but we'll look at it a bit later. There's one CLI utility that is available called log CLI. I was quite excited when I found out about this, the idea of having a CLI binary to just query the logs, and got quite disappointed when I realized that this CLI utility is not actually interfacing with Loki, but it's just using Grafana API. So log CLI actually uses Grafana to execute the queries. So you still have a higher dependency on Grafana even with log CLI in terms of having a nice utility to query your logs. And finally, there's an index gateway.
Sorry, for log
Yes.
CLI, if it uses Grafana interface, that means that it has the same limitations that Grafana would have in terms of querying and setup and all of that. So if it doesn't use Loki directly, it's basically just a CLI that gives you the same result as Grafana would in the UI, right?
Yes, but what limitations did you have in mind?
For example, I was thinking in terms of performance, like if log CLI was working directly on top of Loki, it would be faster to retrieve query logs and stuff like that. But with it being in front of Grafana, it has an additional, sorry, what's the word? I would have thought that if it was directly integrated with logs, with the Loki, querying would be even faster, as an example. I'm sure there's
Yes.
others.
Okay, but no, yeah, it just you basically point it to Grafana, and it just uses an API to communicate with Grafana and execute through that path. And finally, there's an index gateway component, which is very useful. It kind of is a stateful set when you deploy it in Kubernetes because it downloads the indexes from the object storage, the metadata part, and gets in charge of answering queries about that metadata. So if you want to answer questions like how many logs did I have on that day, like how many log lines do I have, or what labels did I have? Well, where can I find how many logs are there with this label? Like those sorts of metadata questions, which do not use the actual content of the logging messages, are all metadata, right? And it gets in charge of answering that part of the queries, those parts of the queries. And the advantage, big advantage you gain by using this component is it allows all the other ones to become stateless. There were, like the querier, for instance, will need access to that data. And without this component, your queries will need to have PVCs and do basically that job for themselves, which makes it very valuable to be able to turn the queries into deployments and have them less stateful. And because the queries is the one you will scale up horizontally for performance or for availability, etc. So yes, yeah, the index gateway seems quite valuable. Okay, if there are no questions, I'm going to move on to how to get it deployed with Launchpad. So it's not terribly complicated conceptually, given that it's mostly about increasing number of replicas. But there are a lot of components. There's here some pictures of what the value setup would look like in terms of just bumping replicas for all the retaining components. But this is just for reference. You should instead go look at our docs, Launchpad docs, where there's a new guides with code snippets for doing exactly this. And it's more detailed and it's easier to look at there. Okay, so it boils down to increasing number of replicas and enabling a bunch of extra components like the index gateway. Highly recommended. Ruler, if you want it, you probably will end up wanting alerts from logs, I imagine. Compactor, you just need one of these. And yeah, kind of doing this. Pretty simple. It's a bit more complicated for Prometheus. Any questions here? Not. Okay, so regarding the monitoring namespace in this stack, there are some notes there. One is Grafana Labs hasn't been investing for a while now in Promtail. They have another alternative called Grafana Agent. It's a collector both for logs and can also scrape Prometheus metrics. So from Grafana, they will point to that as the collector to use in the future. I do have something I dislike about both of them, which is neither of them supports sending logs to a message bus like Kafka. And I do not like that they don't support that because it seems like an interesting component to have for multiple reasons, especially as you go to a very large scale or multi-region setups. And there are some other alternatives you can use for log collecting. One of which is Vector, which is done on Rust and is quite fresh and modern. It looks pretty cool, and it's very has a nice syntax and language to set up basically pipelines for log processing. There's FluentBit, also very well known. And then there's a classic from a different kind of stack, which is Logstash from the Elastic stack. It does not interface directly with Loki, but you can, if your rationale for wanting to use Logstash is that you want to send your logs first to a method bus and then pick them up from there and ingest them to Loki, you can use Logstash for that, send them to Kafka, and then Promptel can pick up logs from Kafka. It does not let you send to Kafka, but it lets you ingest logs from Kafka, and then from Promptel to Loki. There are retention settings you're probably interested in looking at. By default, low-key will retain logs forever. And limiting. I think a proper setup will involve rate limiting at some point. You basically do not want either a malfunctioning or a malicious deployment or a workload or nodes. So just being able to DOS your logging system. That seems like an undesirable setup. Promtail allows you to rate limit, but that would be done at the client side, right? Or at ingesting point size, which is maybe not ideal. Using something like Kafka message bus to ingest logs also gives you that option right at the message bus. You're a bit more limited in terms of how to rate limit at ingress. You can use nginx if your setup is compatible with that. I like to just in the ingress nginx. Or from the log stack itself, you don't have many options. The distributor only allows to rate limit by tenant. You can chain promtails together though.
Um, Carlos,
Yes.
Matthew is asking what kind of setup would be needed to handle, for example, 10,000 or thousands of logs per second, and if we've done any benchmark setting.
We unfortunately do not have a lot of experience to share on that kind of analysis yet. Most of our setup hasn't been like there's this whole cluster we're bringing up exclusively using Launchpad for the effect, which is also driving Launchpad development and all of that. We do have achieved quite a high level of complexity to it already, but not a high level of load. So we're not operating it with a lot of loads, and we don't have that data from using it. And I don't have that data personally either in terms of experience. I do think logs are, I think you gave a number. You said tens of thousands of logs, right?
Yes.
Yeah, that's what I said.
Yeah.
I'm just wondering if it's practical for that level of logging, or we need to consider using other solutions for those kind of debug logs and put more reasonable level of logs into this kind of solution. That was really complex.
I think tens of thousands of logs isn't that much. If you're talking about by logs, we mean like log lines or something like that, because
Yeah, log lines. Yeah.
because if you don't put like a size to the log size actually, and we're talking about like 4 MB blocks each log, then it's different, right? But yeah, tens of thousands of log lines isn't unreasonable. It may not be stuff for like a single instance or a single node, of course, but it's very reasonable. You always have the option of putting a message bus, like I mentioned, in front, which gives you a lot of there's a lot of truth and right tools and data you can look at in terms of how much data can you put into a Kafka, what kind of nodes you need to handle that kind of pressure. And then the message bus will serve as the collectors will not build up pressure because they will just offload it to the message bus. And then you can rate limit from the message bus onwards at the sacrifice of latency. Like if your local stack isn't responding fast enough, you're throttling there and they stay longer in the message bus until they get ingested, and you start getting a delay from the message to you being able to query it or see it. But even without the message bus, I think you can achieve that with not that many instances. I mean,
Cool. I think that's something that Gabriel and Vince are going to have to try.
yes, it's going. You can turn that into a question of, because I'm pretty sure it's probably going to be storage a limiting factor, like storage speed, unless you're using NVMEs for that. But
we're going to need NVMEs for that for sure.
You have your Ceph cluster, right? So object storage there, and yeah, kind of probably going to be a limiting factor. Going to be storage, but they get compressed. And there's one more thing, which is I do know that when you get to a certain scale, it's worthwhile start considering, do you really need all of that? Like, do you need those logs with everything, all the detail? Because you can start filtering or extracting data right at prompt tail. Like if you're ingesting this huge amount of logs and they're like similar, they're just like lines repeating the same stuff, maybe you don't need to send that to message bus or to Loki for it to deduplicate later. Maybe you can start right at prompt tail level and you can apply some transformations there, some filtering, and you reduce from, like 10 kilobytes to 1 kilobyte maybe. It's like a factor of 10. So it's worth, at a certain scale, it's worth start looking at filtering before ingesting, filtering and transforming before ingesting. And there's some space there to get more out of it as well. Does that answer your question, Matthew?
Yeah. Yes and no. Yes, it helps as much as you have the answer to.
Yeah. Yes, I didn't give you the data yet.
So
That's
perfect.
fair. That's fair.
Yeah.
That's fair. Oh, okay.
Well, I'm asking a question that I know you don't have the answer to, right? So I know it's fair. The answer you gave me was fair.
Yeah. How do I get out of this now? Okay, so now we're going to look at Loki in action as soon as got it. As I find out how to get out of full screen. Got it. Okay, so we go through all this. We set up our logging stack, and I'm here in Grafana. If you go after you have it set up, Grafana allows you to go first to have Loki as a data source, and you can go to explore, and you have Loki as an option there, which is a data source which is set up, and you can start using Loki queries. Loki queries are expressions in what they call LogQL, log querying language, which is very, very similar to PromQL, which I think is an advantage on this stack, is that you can kind of treat metrics and logs in a very similar fashion. So I'm just gonna start we have a node here called Ninja, which is actually spewing a lot of errors per second. So I'm gonna use that. I'm gonna filter for. Our logs have a label called nose. Yours will with the default setup, or maybe not. No, I'll go over that next. I'm just set a label on our logs for the nose, and I'm just going to filter for a particular node called Ninja, and I'm going to try and execute this query, which is erroring out. Maybe I need to refresh. Yeah, I needed to re-authenticate here. And hopefully now it does work. Okay, there we go. So this is a very basic query for Loki, and we get on Grafana up to 1,000 results. Then it just kept here in terms of visualizing a lot of messages. Like I said, this node has a ton of directory received from the PC bus. Just constant stream of error messages like this. Okay, what else can we do with this? So we have these messages, and if you look at them, we can see they're basically JSON formatted. So what we can do is use a parser. JSON, there's log format is another one, but Loki has a couple of them. You can find out all about this on Loki's documentation. There are like a lot of functions and things. And the basics syntax of the expressions is you do a selection, and then you have like a pipeline, and you just like pipe things forward, like chain them to process it further sequentially. So now that I'm parsing them with JSON, I've got a whole lot more fields than I had before, which are all the fields that I had in JSON. These fields are what will become labels for the logs. So I can, after doing this parsing, now I have all of these labels. So what else can I do now? I can turn this into a metric, which is something very cool. I have this selector, and I'm parsing it to JSON, and I could apply some filtering. Now I'm going to take the message field, and I'm going to say that it's equal to. Here I'm using equal entitled for a rejects met. PCE bus error. So if I do this, all the message I get should have that. Maybe I missed one of these here, but I don't think I need that one. Yes. Okay. So now my results are just all of those error messages, right? So now let's say that I wanted to count them. Like I wanted to turn this into, I want to know like the rate of these error messages in intervals of 5 minutes and build a graph out of that. Where it will create me data points. I run this query, I get an error. Maximum series 500 each for a single query. And the reason I get this error is because when I parse it to JSON, it starts having all of those fields, which will be labels. And now when it tries to turn this into a metric, it's going to have a really high cardinality because there's all of those different labels on the metrics. So what we can do is we can drop all of them because we don't want them. You could use drop and drop specific labels now, or you can just keep and whitelist the ones you want to keep. And I just want to keep nodes and message. And it should work like that. And you'll see like on the message, and there we go. And now I've just produced metrics out of my logs. And that yeah, and this gets exported also as a scrapable metrics target. So our metrics stack can scrape the result of those, and they end up as metrics you can query on Prometheus, or as you see later, Tainus. So here we have, and if you go to our log sample now, you'll see that the fields got drops, and we're just keeping those two. Just going to show one more thing, which is we can also use regex to extract something. Let me go back to a simple query. Say you want us to actually build labels out of the message contents. Because if you want to build metrics, you want to be as minimalistic as possible on your labels because of cardinality. So you probably want a lot of control over them, like which ones do you keep. Maybe there's important information on the content of the message that you want to use as a label. Or the metrics. So let's just try and extract something. I'm going to take one of these messages and I'm going to do a regex expression. And I'm going to extract this device ID, like this parameter here as a label. Which is basically, I probably don't need to go over this, but it's basically do a capture group. You name it, like live from LOH, and you just need to match it. I need, let me see. Okay, it's just going to be NVMe. I'm looking at this here, NVMe, and then numbers. So NVMe space, then my capture group, which will have, I need to double escape this, numbers for numbers followed by this, more numbers. A dot and a last number, and then at the end, yeah, I'll do it colon again. I think this should work. If it's I messed up the syntax, it should execute, and we should end up with a new label on our log lines called live from LOH, which value is extracted from that message there. That's what happened. Yeah, okay. So there's a lot of functions to this. Regex also already gives you kind of a lot of power. Don't ask me if this supports look ahead. I haven't checked yet, and I haven't used it. But do go look at what it does support before starting to use Regex for everything, because it has a lot of functions. For instance, there's an IP function that basically allows you to give it an IP or a subnet, and it takes care of matching a certain element, looking for that, for an IP fitting of that subnet, things like that. So there's a rich toolkit of functions and things you may be able to use that do a better job than you having to write regex for everything. But regex is a very general and powerful on its own right. So here, this is what you kind of get with a Lockit stack. Well, more than that. Then you can turn this into alerts as well, but we'll go over that next, after the method stack. Any questions here? And then this takes a bit. So now we either will do Q&A or we will start with the Prometheus stack, which we probably won't be able to finish the session, which I will keep going unless you guys want to have some questions to talk about Loki a bit.
Just one other, just a quick comment about the Prometheus and metrics and stuff like that. Just to clarify for everyone, because we've done previous sessions on the Prometheus stack and stuff like that. This is taking it to the next step of making sure everything is highly available. So it includes that whole everything you need to consider for high availability.
Yes, there's in the present moment it's a little bit harder to set up using Launchpad, mainly because let's get there. Let's look at the stack first. So we have Prometheus. I think everyone here is probably familiar with it. Yes, go ahead.
I think Vince might want to share about Pinax's experience on Loki.
Of course. I'll go ahead, Vince. Let me check here.
Yeah, I don't know if Vince has anything to share, or there was some discussion earlier about what was it called? Gabrielle, you brought up the tracing stuff. So I don't know, like instead of getting into Prometheus today, I don't know if there's worth some discussion about.
Yeah, I agree.
So
I think
far.
it would be better to separate the Prometheus stuff into the next session.
Yes, that's a good idea. Please go ahead.
So Vince or Gabrielle, share what you've been doing with our stack and what you've learned or any interesting experiences. Or they're all quiet today. Vince, we can't hear you.
Oh, I had it on push to talk.
There we go.
Yeah, so we're using the same kind of setup, the kubestack Prometheus. Our most recent thing. Hold on, am I able to talk without push to talk? Let me set that off real quick.
Hopefully. That's annoying to have to keep holding down the key. switch to the other Vince.
Still working? Yes. Yay. Yes. So we're using the Prometheus stack with and deploying it with Flux. I guess our more recent thing wasn't so much Loki as it was doing Alert Manager was our most recent thing within the whole monitoring stack and getting Alert Manager going and making that talk to PagerDuty and making that talk to Discord and all that kind of stuff. And so far, the experience has been pretty good. The syntax with Alert Manager was a little confusing. But once I kind of got that figured out, it's been a lot better. We are going to be using tracing as well. But the Loki experience, it was pretty positive for me because I'm quite used to Loki. So I didn't really have much issues there. It was just the Kubernetes part of it that was a little more tough. Um, but yeah, the Loki works great. I posted a dash above that I like to use with Loki, and it kind of just grabs the whatever app, and then you can put in whatever string you want on that app, and it will just grab those logs for you quickly. I think that dash is amazing. It's simple, but it's really powerful. But other than that, I don't really have a whole lot to share. I mean, it's been a pretty simple process for Loki, besides getting it on Kubernetes part.
You probably have a better perspective in terms of hardware to performance than we do at the moment. Like it seems like you have a lot more logs going on.
Yeah, we haven't fully pulled in the entirety of what PinX is doing, like the terabytes of logs that Matthew was talking about. We kind of have a smaller stack where we're just running substreams and a few other things. So we're not at all getting inundated with logs right now. But as we start pulling in more core parts of stuff into Kubernetes and then grabbing those logs, that's kind of where we're going to see, any roadblocks as far as what happens. And we're probably going to have to tune and filter the logs so that it's not just completely inundating us with, debug messages or something that are completely useless. And it might be a per app thing where I don't need it for this. Let's tune that down. So,
Yeah,
yes.
I think.
To Chris's question,
Nice.
yes.
Nice. I was going to mention this. I really think for that use case, you may want to look at those alternatives I listed because they offer you like some means to make some really cool-looking pipelines to process that. Because I think you're probably going to end up looking at wanting to implement more of it on the collection side or having some kind of a message bus where you do like multi-stage processing to like filter out or to just rate limit. If you can spread things out in different channels and put a limit to them, you're better. You probably prefer to have a system where some workload is running on the bug message, but it was producing too much and it was gonna be more than the system Loki can handle. So you're rate throttling them and just like dropping messages and not keeping all of them at that point and just making your whole logging system come to a crawl, right? It's like you probably want that safeguard, and for that you probably want to be able to rate limit or to cap and segment it in different channels and do all of that. So that's more elaborate pipeline work and all of the config setup for the collection part or the pre-ingesting them to Loki. So yeah, you may want to look at those tools too. They seem to offer more modern and cleaner syntax sometimes and etc. There's one thing I'd like to quickly add, sorry, and related to this, which is there's one thing I'm not happy with regarding Loki and setting it up with that chart and using Launchpad for it, which is adding roles. Adding roles comes in as kind of an array of roles you can add to the setup under values. And what happens with that array is that the chart takes that array and builds a config map where each key is one of the roles and it mounts that config map on the ruler deployment, where it shows up as files on a dir, so that the ruler process can access those rules. The thing I don't like about that is that it makes your ruling setup centralized on that chart. So say you want to deploy some workload and you wanted to bundle an alerting rule with it. You kind of have to go to your values file for the logdish chart and add it there instead of alongside your workloads. Like on Prometheus, we have the operator, so you can bundle those Prometheus rule CRDs just with your workload and keep them together. So it's one thing I would like, even though it's not like a super priority in the future, would be to just develop like an init container that will just have a role to access config maps on the cluster with some sort of label, and basically do something similar, but at runtime, we'll just catch the cluster where config maps and just kind of process them and put them as files on the disk for ruler. Give it like more dynamic runtime loading of resources, and then we could just keep config maps with Loki roles, and it would work. And I think that would be better. Sorry, okay. I wanted to mention that I think shortcoming in the moment of that start.
Yeah, I was just gonna add, if you have any relevant links to what you were speaking on as far as like scaling and running into those, limited resource things, if you have any relevant links on that, that would be awesome.
Not at end. I do have like the link Chris just posted is like basically guidelines or examples of configs that would allow to set up these stacks as highly available. So yeah, because right now we do feel like the default values in setup we have, there's some shortcomings. Like we don't have a chart yet. We probably need to add that one, but that's going to be covered on the metrics segment. And we'll probably end up having a highly available flavor just so that we have a baseline of default values that are suitable for AJ, and reduce that distance of how much stuff you have to configure to get like a basic AJ setup going. Right now, you do have to pass a lot of values to set up a lot of things.
Are those chunk values and the max chunk age something we're definitely going to want to be playing with? On the Loki
just
home
like
chart?
the for instance, on Loki it will be more like number of replicas, and people end up setting those up. I think our default is a bit outdated for the index schema star, which is both DB shipper, and currently it will be highly recommended to be using TFDB as the index star schema. There's that setting, which I think is very relevant as well, and I think this applies more to the Prometheus stack because of the lack of sanus card in the monitoring namespace. The need for a Grafana database, and all. We'll cover that on the next one when we proceed. But yeah, for log, it's not too bad. Oh yeah, and Matthew is going to like this one. And then there's the fact that for all of this, you kind of need object storage. And we don't really support object storage in the storage namespace, right? We probably, it's the requirement for for all of this in terms of availability. It's also a requirement for firehose, so we may end up having like root operator, a chart for it as an option. Which will be then mostly about documentation because all of the setup is fair use, right? But at least ship the operator with it as a release. Yes, indeed, Matthew. Given we're approaching the end of this, I just want to start out like as Billy was saying, feedback, but especially now, as next session we're going to go over the Prometheus stack, and then we'll go over actual using these stacks to approach real world or valuable scenarios like use cases. So it will be a bit more heavy in terms of alerts and silencing them and doing queries with Loki and like dashboards and Grafana, stuff like that. If you guys do have like use cases in mind or things, like just submit them because it's going to take us a couple of sessions to get to the end of this, so there's still time for you guys to influence the content of those sessions. Have you used NVMe with Ceph before, Matthew?
Sorry, NVMe with Ceph?
Yes.
I mean, this should be no different than doing HDDs. We just need to set up different pools for the different data and then put the right buckets in the right pools.
The big difference you're gonna see, I think, is that for you to get the maximum performance out of an NVMe, you will be using like 4-6 CPU cores per NVMe in terms of loads.
Sorry, using what?
The OSDs for those NVMEs will go up a lot higher in terms of CPU consumption compared to HDDs.
For sure. For sure. Yeah, so we have 6 NVMe drives in the current Ceph cluster, but they're just used for the object index. It's not actually the data that's stored on that. But the CPU on those is quite high compared to the CPU on the HDDs that's storing the firehose blocks. Yeah. Correct. Yeah, we need high performance machines for the NVMEs for sure.
Yes, I just want to give you a heads up on that in case you haven't experienced it yet.
Yeah.
I think we're at time. So any last round of questions? And please do submit feedback if you guys want to see something covered along this subject in the next sessions. Oh, what's this? The lows average 53. There is a lot of RAM as well. You're just flexing, Matty. That's some powerful nodes.
I guess a quick question though, kind of, I guess since we're talking about storage, I've been, or we can cover it in the future. So the kind of next two pieces, that we're doing. The main one being storage is the next one, and I've been kind of researching what we should use in our cluster because obviously we need to keep up with blockchain and at large scale. And I was wondering if anybody had any thoughts on OpenEBS Mayastore. It seems like that is possibly the way I want, or the path I want to travel. But if anyone has any, hey, don't do that, or better suggestions, I'm super open to it.
Yeah, I don't have a better suggestion. I haven't used Mayastar. I know about it. I've looked at it, and for NVMe, it seems to be it's the project that's most focused on that specific use case, which is be as fast as possible, like low latency and all of that. They support the NVMe over TCP protocol thing. I think it's where I would go as well. I know there's some other projects that kind of compete with OpenEBS. I think there's one called Longhorn or something like that, but it's not as focused on as Mayastar is on just having the lowest latency, which is what you actually want. Does that apply to all block sizes? Oh, if ext4 on top of ZFS works okay. Interesting.
Yeah, I did a lot of tests trying to get Aragon to work on native ZFS. Maybe I need to do more tests, but storage is painful. So that's what we're working on now, as Vince mentioned. Trying to pick the right storage system. So, the network's gonna, we need to get Polygon Aragon and Polygon BSC running at peak performance. So that's what I've been testing outside of Kubernetes. And then Vince is trying to figure out what the config is inside Kubernetes for that.
Yeah, no, Vince, I will be looking at Mayastar as well. And if you had like unlimited funds, I'll probably, instead of being looking at node local storage, I'll start looking at NVMe over TCP, who is like really fast network. And just do like a storage cluster that just does storage, and you have network storage, but fast enough. Exactly that way. You could do that, but that's expensive. Specifically because you're gonna you're gonna you're
I
gonna
don't
want
think
really
we're going there. I don't think we're going there.
yeah. But it does give you back network storage, which is just so much more practical.
This is the
Yeah, and I was
interesting.
also
Go ahead.
I was also looking at Mayastor because it seemed really interesting because it said it supported ZFS, XT4, XFS, and ButterFS, and you can also just really easily just do kubectl volume snapshot with it, even if you have XT4 or XFS, and it's fast. So that's kind of why I've been looking at it, because I have the opportunity to do snapshots, but also use XFS, which is really interesting.
Yeah, it does look like a step up from C-Star in terms of performance. And like Chris says, I also had that impression that it's more recent and it started it's like not at future parity or anything like that, but it's been actively developed. And if you don't need the latest that kind of performance, C-Star would be like the older product that is more polished and like less buggy potentially.
Yeah, just
Okay.
especially with blockchains, I really am leaning towards XFS. because that's just kind of where we're at with file storage, and some of these chains like Harmony and BSC, they really need XFS.
Yes.
Yeah, so we have this interesting dilemma as, easy to use versus high performance, or most awesomest performance. It's not just high performance.
It's not actually a real dilemma, because the high performance in this case is not a want to have or nice to have. It's not usable if you don't have that.
RAM disk, sure. Let's put the Aragon 8 terabytes into a RAM disk.
Yes, everyone tried Optane disks from Intel. Those Optane disks.
Yeah, exactly. So we have to balance the cost here. Anyway, that's where we're at.
Okay. One thing we'll also have to work with recently, and maybe of interest to you guys, and we'll cover at some point after monitoring, is databases in Postgres operator, namely its backup system with like WAL-V or WAL-E, and putting that into object storage and all that. You probably already have experience with that, Matthew, I imagine. But if not, that's also going to get covered eventually, as we've been using that ourselves. And it's pretty nice, works really well so far. That's been our finding.
All right. Well, we're always interested in what you've played with, experience, whatever, and please ask us the same questions back, so Vince and Gabrielle can share with you what our experience is.
Will do. Thank you.
Okay, I should go. I need to go play around with RPC notes. Thanks for the content today. See you in 2 weeks.
Yes, and I think we're done, right, Billy, Anna?
Yes, thank you, everyone, and thank you, Carlos and Matthew, and contributing. And we'll see you in 2 weeks.